in a parabola, again 2a upon r is equal to 2a upon r is equal to 1 plus cos theta. Okay, 1 plus cos theta. We have to prove that in this parabola, to prove that s is equal to, or ds upon d psi is equal to 2a upon this. I think we have proved in question number 2. Okay, that was earlier one. It was having that result, but this is a part of this, I think, because we had proved this ds upon d psi was equal to 2a upon sine q psi. Let me take this. Okay, so in this parabola, let me take solution. So let me prove this. What is the solution of this? Here r is equal to, so we have 2a upon r is equal to 1 plus cos theta, or r is equal to 2a upon 1 plus cos theta. Simple. We have divided this or taken r to this side, so r is equal to 2a upon 1 plus cos theta. But we know that 1 plus cos theta is 2 into cos square half theta. Why? We know that since cos 2 theta is equal to 2 cos square theta minus 1. If I take minus 1 to this side, then it will be 1 plus cos 2 theta equal to 2 cos square theta. Trigonometric identity, try to understand. Now if this angle is twice here, angle is single. If it is single angle like this 1 plus cos theta, it will be 2 cos square theta by 2. This we have written down 2 cos square theta by 2. Simple. This is the value 2 to cancel out. So here we obtain a into this is secant square half theta is the value of r here. Therefore, now this is equation number second. Okay. Oh, sorry. This is the first equation. Okay, let me take this first, this second. Now therefore differentiating it with respect to theta. Differentiating with respect to theta. We get, what do we get here? dr d theta is equal to, here dr d theta is equal to twice a into secant 1.2 theta. Again secant 1.2 theta is to be differentiated, so it will be secant theta into tan theta. But here 1.2 of theta, coefficient of theta is 1.2. So we have to multiply this by 1.2 because 1.2 theta, the angle is to be differentiated again. If it is other than theta, so this is 1.2 theta. The coefficient of theta is 1.2, so we have to multiply 1.2. These 2 to cancel out. So this we have obtained that this is secant to sec square 1.2 theta into tan 1.2 theta. Okay, this is the value of dr d theta. Now, what is ds upon d theta? Let me find out that. Therefore, ds upon d theta, because r was here a into secant square theta, so r was here a into secant square half theta. This was value of r which we took second equation. Now dr d theta is this, and dr d theta we have obtained here is a into secant square half theta into tan half theta. This is value of dr d theta. But we know that. Now what is value of, okay, this is dr d theta, but ds d theta, we know that whole square is equal to, this is r square plus dr d theta square. This we know about it from the length of the arc formula. ds d theta is equal to r square plus dr upon d theta. So r square is this value. This is a square into secant 4 theta, 4 power theta, plus dr d theta is this square. So this is a square into secant 4 half theta into tan square 1.2 theta. We can take now a sec a square sec 4 1.2 theta common. In the bracket it will be 1 plus tan square 1.2 theta. This 1 plus tan square theta is secant square theta. It is nothing but a into secant square into sec 4, that means sec 6 half theta. Therefore, ds d theta, try to understand, is equal to a into secant cube 1.2 theta. Secant cube 1.2 theta. Okay. So we have to calculate what is that ds upon d psi. We have to prove that ds upon d psi equal to this. We have to find out ds upon d psi, but this is ds upon d theta. Try to understand. It means what is the relation between psi angle and this value. Dr d theta is this. So we know that what is tan phi. Since tan phi angle is equal to r into d theta upon dr. Try to understand. This is r square, r upon dr upon d theta. Dr upon d theta is this divided by, and r is this. So r is, or we can write r upon d theta. Okay. So that will give us, let me take this further. It will give us r is a into secant square half theta divided by this dr d theta is a into secant square 1.2 theta into tan of 1.2 theta. This secant square cancel out, a cancel out, so this is 1 upon 10. Let me write 1 upon 10 square 1.2 theta. Sorry, 1.2 is tan theta only, I'm not a square. 1.10 1.2 theta only, not a square, I'm sorry. This is equal to cot 1.2 theta. Now this can be written as, now we have obtained here ds upon d theta is this value. So what we obtained here, tan phi is equal to cot of 1.2 theta. Now this can be written as tan pi by 2 minus half theta. Got tan pi by 2, 90 minus theta is cot theta. This is cot half theta. Cot half theta can be written as tan pi by 2 minus half theta. Same value. So this tan phi equal to tan this. So angles should be equal now. Therefore, let me write here dr d theta. This is ds upon d theta. So let me write here. Okay, let me write here. It means ds upon this phi is equal to, your phi is equal to pi by 2 minus half theta. But we know that psi angle equal to theta plus phi angle. Okay, exterior angle psi equal to interior 2 angles. So here we can substitute value of phi. Phi is this. This is pi by 2 minus half theta. Pi by 2 minus half theta. Okay, so pi by 2 minus half theta. Now let me develop this. So therefore pi by 2 minus half theta and theta minus half theta. So psi angle is equal to 1.2 theta plus pi by 2. What half theta is equal to psi minus pi by 2. Try to understand. Now if I put half theta equal to psi minus pi by 2 in this equation, therefore ds upon d theta, this is equal to a into secant cube psi minus pi by 2 angle, half of this, sorry, yeah, half theta, because this is half theta equal to psi minus pi by 2. It will give us, because secant 90 minus theta, or it can be written as a into secant cube, because secant is even function. we can write it pi by 2 minus psi by taking a negative angle common. But at negative angle doesn't change sec, because sec and cos, they are even functions. They remain positive. This is now sec pi by 2 minus theta is cosec theta. So it will be, here it will give us a into cosec q psi. This is cosec psi, the cosec q psi angle. Okay, now we have to find out what we have to prove, that d psi upon ds upon d psi. Now we have to find out what is ds upon d psi can be written as, but here psi angle is this, or half theta is equal to psi minus pi by 2. If I differentiate it with respect to psi, sorry, with respect to theta here, therefore d psi upon d theta is equal to 1.2 only. Why? Because theta is 1. We are differentiating it with respect to theta. D psi upon d theta. Psi is we are taking it as a as a variable. So d psi upon d theta is equal to 1.2 only. Theta is 1. So this is 0 constant. Constant is 0. So d psi upon d theta from this equation, because half theta is equal to psi minus pi by 2. D psi upon d theta is 1.2. Okay. Now we have to find out this ds upon d psi. Sorry, ds upon d psi. So what is this? We write ds upon d theta into d theta upon d psi. No change. Or we can write it as ds upon d theta divided by d psi upon d theta. Simple. Now ds upon d theta is this. So finally, what we obtain, let me write here. Therefore, ds upon d psi, which is this value, which is ds upon d theta divided by d psi upon d theta. This one. Now, what are these values? Ds upon d theta is this, which is a into secant q half theta. Sorry, this is not to be written down. Ds upon d theta is this cosec. But in angles psi we have to find out. This is a cosec q psi. This ds upon d theta is this value in terms of psi angle, because we have to find out the relation between s and psi angle. That is intrinsic equation. ds upon d theta upon d psi upon d theta. So d psi upon d theta is half. We just calculated here. D psi upon d theta was 1.2. This is upon 1.2. This 2 will come in the numerator. This is twice a into cosec q psi. Why? This d psi upon d theta, I just clarified that because half theta is equal to psi minus pi by 2. Then we differentiate with respect to theta, psi, d psi upon d theta, therefore by 1.2, because theta is 1. So this is the value, twice a cosec q psi, or it can be written as twice a upon sine q psi. Simple. But cosec is 1 point sine. So this is the final value which we have to prove. Therefore, ds upon d psi equal to twice a upon, this is twice a into cosec q psi, maybe this is the answer, or this twice a upon sine q psi. Okay, this is the, I think, proof. We have to prove this. ds upon d psi equal to twice a upon sine q psi. ds upon d psi, to prove ds upon d psi is twice a upon sine q psi. Simple. This is intrinsic equation, or which we have to prove here, hence proved. Okay, so this is question number 4 we have done. Okay, now let me take fifth question number 5 here. What does it say? question number 5, let me check what it is giving. 13 here, and this is the 14 here. 15. Total 15 questions are taken here. I'll take them one by one. Now question number 5 says, find the intrinsic equation of the cardioid r equal to a into 1 plus cos theta. Okay, and then prove, and hence or otherwise prove that s square plus 9 rho square equal to 16a square, where what is rho? Where rho is the radius of curvature at any point, and s is the length of the arc intercepted between the vertex and the point. Okay, and at that point, so we will take again 0 to theta angles. I mean, if we have to take the angle theta, so that is from intrinsic equation we have to find out. Okay, so first we have to find intrinsic equation s square, or in terms of s. Then we will find out what is the rho here. Rho is d psi upon d theta. Okay, sorry, ds upon d psi. Here rho, which is radius of curvature, is given by d s upon d psi. Sorry, the ds upon d psi, which is represented by rho here. That is known as radius of curvature. So this we will calculate. That is the point. Okay, so question number 5 here, to find intrinsic equation of the cardioid. Okay, of the cardioid here, r is equal to a into 1 plus cos theta. Now if I put theta is 0, then this is 1 plus 1, 2a. So r is equal to 2a. What is this kind of cardioid? We know that this is the cardioid here. I'm sorry, the lower part I have taken very, okay, smaller one. So this is the cardioid here. This cardioid here, x-axis, this is origin, x dash axis, y, and y dash axis. Now point is here that at this point theta is equal to pi here. At this point theta is 0. Theta is 0, so this is twice a 0 point. So the radius is here twice a. Why twice a? If I put theta 0, 1 plus 1, 2, twice a, r equal to twice a. So this is r from this point to this point is twice a. This is twice a here. Okay, at pi, when theta we put, theta put pi, cos pi is minus 1, so 1 minus 1 is 0, r equal to 0 here, here it is 0, here r is 0, theta at theta 0, this is the point here. Now if we have to find out, let me take length of this arc here. Okay, if I take a tangent line at this point like this here. Okay, so this is the psi, this is theta angle, or we can take theta angle here like this. We can take the angle. Now this is phi angle. We can take theta, phi, and here and psi angle is this. Psi equal to theta plus phi. In this way we will calculate this. Now let me take figure is like this. Now just to save the space here, let me solve the question. Now so what is the question here is solution. I'll change the marker. Okay, now it says to find the intrinsic equation of this cardioid. Okay, and to prove that, what we have to prove here, and to prove s square plus 9 rho square equal to 16a square. Try to understand. This is we have to prove. Okay, now let me check that what is the point here. This is s, the length of the arc between 0 to theta, that we have to take here, because from vertex at a vertex 0, 0 is there. Okay, so find the intrinsic equation of the cardioid r equal to a into 1 plus cos theta, and hence or otherwise prove that s square plus 9 rho square equal to 16a square, where rho is the radius of curvature. Here rho is radius of curvature. Here rho I have written down ds upon d psi, that is known as radius of curvature. Now length of the arc, where S is the length of the arc intercepted between the vertex and the point. Okay, and the point on the cardioid. So that is the at the vertex 0, 0 is there. So theta is 0, 0 to theta we will take. Now relation between theta and psi we have to find out. So let me take here. R is here A into 1 plus cos theta. Simple. Therefore, dr upon d theta, or differentiating it, this is first equation, differentiating it with respect to theta, we get dr upon d theta is equal to, this is A into minus sin theta, this is minus A sin theta. Differentiation, cos theta differentiation is minus sin theta, this is minus A sin theta. Okay, now ds upon d theta, we know since ds upon d theta is under root of r square plus dr upon d theta whole square. Simple. And now this is r square here. R square is a into 1 plus, or a square into 1 plus cos theta whole square plus dr d theta is this, so this is a square into sin square theta. Okay. Here we can take a common out of this square root. Let me solve it. The ds d theta will be applied then directly. Okay. Now this question gives us, this is 1 plus cos theta whole square. That means 1 plus cos square theta plus 2 cos theta plus cos sin square theta, because a square we have taken out of the square root. So it will give us sin square theta plus cos square theta is 1. This is a into 1 plus sin square theta plus cos square theta plus 2 cos theta within the square root. It will give us a 1 plus 1. This is 2 here, 2 plus 2 cos theta. 2 plus 2 cos theta. Okay. Now let me further solve it. Then it will give us, let me write here. So ds upon d theta we are calculating. So it will give us a under root. Let me take 2 common here. This is 1 plus cos theta. Okay. And it will give us a 2 into 2. This is cos square half theta. Try to understand. So it will give us twice a. 2 can be now taken out of the square root. And cos square half theta is there. So it is cos half theta only. The square root is cancelled out. This is the ds d theta value. Now let me take. What is the final next thing? Now next thing, which is ds upon d theta is, sorry, this s equal to, let me find out. Therefore s equal to s length of the arc. Now here limits are, okay, so limits are 0 to theta here. Now twice of this or whole length, find the intrinsic equation between. Okay, so intrinsic equation we have to find out. No problem. So let me take s here. S gives us twice a. This twice a I have taken outside. This is ds upon, let me write, this is ds upon d theta into d theta. Ds d theta is this value. The twice a that I have taken outside, and let me take cos half theta into d theta. Cos half theta into d theta. It is giving us twice a into, this is nothing but sine of half theta upon half, that means twice 0 to theta. It is giving us only sine of 1.2 theta. But theta is, we are not taking 0 to pi by nothing angle. Angles are not given there. So it is only 4a, this is 4a sine of 1.2 theta. At 0 it is 0. I have taken this s equal to this value, 4a sine half theta. Okay. Now this is value of s here. Now what is rho? That we have to calculate. First of all, we have to find out what is the relationship between psi angle and theta. That let me find out. Here we know that tan phi equal to r into d theta upon dr. This is equal to r is here, this a into 1 plus cos theta divided by dr upon d theta. Dr upon d theta was minus a into sin theta. This is dr upon d theta. That means this gives us a cancel out. Now here it is twice cos square theta half theta divided by this is twice minus sin half theta into cos half theta. Got the point? Cos half theta. So one cos cancelled out and this 2 cancel out. So this is minus cot. This is nothing but minus cot. Let me write here. It gives us minus cot half theta. Now minus cot half theta, if I have got this is negative sign, cos 1.2 theta upon sin 1.2 theta, that means cot half theta. So let me take this as this is cot of. Now it can witness tan pi by 2 plus half theta. Try to understand why? Because in second quadrant tan is negative, only sin and cosec positive, others are negative. So this is pi by 2 plus theta, means second quadrant. After first quadrant, this is the second quadrant. This is pi by 2 plus theta, and this is first quadrant, second quadrant, third and fourth. In second quadrant, only sin and cosec positive. This is tan here, tan negative, so this will become cot tan 91 theta is cot theta, but it is negative. This can be written like this. Here we see that theta is going to, therefore phi is equal to pi by 2 plus half theta. This is value of phi, but we know that. Let me now write. Okay, but we know that no ds upon d theta was okay, but to be that required. Okay, that will be calculated later. Now here this is s here because s is required. Okay, and ds upon d theta. What was ds upon d theta? Ds upon d theta. It was ds upon d theta was twice a cos 1.2 theta. Here ds upon d theta was twice a cos 1.2 theta because that we have written here. Now let me take this psi. We know that since psi equal to theta plus phi. Now here theta as it is, phi is this value, pi by 2 plus half theta. So this is 3 by 2 theta. 3 by 2 theta plus pi by 2. Therefore half theta if I calculate. So this is half theta here. With half theta we have to replace. So half theta therefore, well, let me rub this. Therefore this psi equal to 3 by 2 theta plus pi by 2. If I take pi by 2 to that side, it will be psi minus pi by 2 upon 1.3 equal to 1.2 theta. Try to understand. This upon 3 are taken from this. This is value of 1.2 theta. Okay, this is theta value. Now we can replace this theta with psi minus this value. So we are given here s equal to, therefore here s equal to twice a, sorry, this is 4a, let me write here, this is 4a upon 3. Why? Because this is 1 point, sorry, angle is 1.3, I'm sorry. So this is 4a into sine of 1.2 theta is this. This is 1.3 psi minus pi by 2. It will be cosec, no problem, but let me take the same angle. Now what is the next thing? So this is to be applied here. Let me take this third equation or second equation. No change, no problem. Now this is the second equation, s equal to this value. What is sine? This is second equation, and this, let me take third equation. Okay, now ds upon d psi, which is rho. So ds upon d psi, we know that. What is ds upon d psi? This is rho here. Since rho ds upon d psi, is equal to, we can write it as ds upon d theta into d psi upon d theta. From this d psi upon d theta we can calculate. So this is d psi upon d theta, okay, and this is d theta upon d psi, or we can write it as ds upon d theta upon d psi upon d theta. What is d psi upon d theta from this 3/2 only. D psi upon d theta is 3/2. So we can write it as ds upon d theta. Now ds upon d theta was twice a into cos 1.2 theta. This was the value of ds upon d theta, I think. Yeah, that was there. Yes, d theta is this. So this is twice a cos 1.2 theta, but theta can be written as the same angle psi minus, this is psi minus here, okay, these are cancelled, no problem. This was 1.3 psi minus pi by 2. This was the angle of theta. So ds upon d theta was 2a cos 1.2 theta. It was 1.2 theta is from this value we calculated 1.2 theta. Okay, let me write again. This is 1.2 theta was, yeah, it was 1.3 into psi minus pi by 2. Simple. Psi minus pi by 2. If I take this, so half theta in place of half theta, this 2a cos 1.2 theta, which was value of ds upon d theta. Here we have to substitute, divided by, now let me write ds upon d theta. What is this here? This is nothing but 3/2 theta. Sorry, ds upon d theta is 3/2 only. Why? ds upon d theta, if I find out from here, ds upon d theta is 3/2 theta is 1. This is 3/2 only. So this 4/3. Therefore, rho is equal to, so rho equal to, now ds upon d theta. Now if I find ds upon d theta is, therefore 3/2